Every day, millions of people type prompts into ChatGPT, Claude, or Grok and get answers that feel almost human. Here's the uncomfortable truth. The model has no idea what it's about to say. Not the full sentence, not even the next word. It's generating your response one piece at a time, and each piece is a probabilistic guess picked from over 100,000 options. Let me show you exactly what happens. We're going to send a single prompt, explain Python to a beginner, and watch it travel through every stage of the mechanism from the moment you hit send to the moment text starts streaming back. 5 steps. Break it, map it, understand it, score it, choose it, then loop. Once you see it, ChatGPT stops feeling like magic. Step 1. Break it. Lens don't read words, they read tokens. When you type explain Python to a beginner into OpenAI's tokenizer, you get 5 tokens, 1 for each word in this case. But that's not always how it works. Common words like the get 1 token, uncommon or long words get chopped into subword pieces. Indistinguishable, 4 tokens. This all happens before the model ever sees your input. It's a pre-processing step, learned from patterns across massive training data. Every token then gets a number, a token ID, so your prompt becomes a sequence of 5 integers. That's what actually enters the model. This is also why character count and token count are not the same thing, and why an API's max 4096 tokens limit is roughly 3000 words of English, not 4000. Step 2. Map it. Every token ID gets converted into a vector, a long list of numbers representing its meaning. And when I say long, I mean it. GPT-3 uses over 12,000 numbers per token. These aren't random, they're coordinates in what you can think of as a meaning space, where words with similar meanings end up near each other. Our 5 tokens, explain, Python, to a, beginner, each land somewhere in that space. Python sits near JavaScript and programming. Beginner sits near novice, learner, student. Python the snake would sit somewhere completely different. There's a famous demonstration. Take the vector for king, subtract man, add woman, and you land near queen. The model learned gender relationships from text patterns alone. Nobody hand-coded that. This is how the model already understands, before any real thinking has happened, that our prompt is about programming and about someone new to it. Step 3. Understand it. Your embeddings flow into the transformer, a neural network with billions of parameters. The one mechanism inside it worth understanding is called attention. Here's what attention does. Take this sentence. The cat sat on the mat because it was tired. What does it refer to? The cat, not the mat. When the model processes it assigns high attention weight to cat and low weight to mat, even though mat is physically closer. It learned this from statistical patterns across millions of examples. It was tired pattern matches with animals, not objects. Back to our own prompt. When the model processes beginner, attention lets it look back and weight Python and explain heavily, connecting the audience of the answer to the topic. This calculation happens many times in parallel through what are called attention heads, each capturing different relationships. And then the entire layer repeats. GPT-3 has 96 layers stacked on top of each other. Llama 3's 70 billion parameter model has 80. Each layer refines the representation. Each layer builds more abstract understanding. What comes out is a set of vectors that encode not just individual token meanings, but rich contextual information about the entire input. This is also why clearly structured prompts tend to perform better than rambling ones. Cleaner structure gives attention cleaner signals to weight against. Step 4. Score it. The final layer produces a score for every single token in the vocabulary. Llama 3 has 128,000 tokens. Each one gets a score. These raw scores are called logits. A function called softmax then converts them into probabilities that all sum to 1. For explain Python to a beginner, the model might now be looking at something like Python at 31%, it at 17%, a at 11%, and 127,997 other tokens splitting the rest. This is the core reality of how LLMs generate. The model doesn't decide what to say. It produces a probability distribution over every possible next token. Your final response is just one path through an enormous space of possibilities. A walk through a forest where every fork has 100,000 branches, and the model quietly picks one at every step. Step 5. Choose it. This is where you get direct control. The simplest approach is greedy decoding. Pick the highest probability token every time. Consistent? Yes. Boring? Usually. Which is where temperature comes in. Temperature adjusts how confident the distribution is. Low temperature sharpens it. Safe, predictable choices dominate. High temperature flattens it. Unlikely, tokens get a real shot. Push it too far, and outputs start to fall apart. Then there's top P, also called nucleus sampling. Top P says, only sample from the smallest set of tokens whose probabilities add up to P. If top P is 0.9, you might be choosing from 15 tokens or 500, depending on how confident the model is at that step. Rough starting points. Code around 0.2 to 0.4. General tasks around 0.7 to 1.0. creative writing higher. Different APIs interpret temperature slightly differently though, so check your model's docs before locking anything in. One more thing that surprises people. Even with the exact same prompt, 2 runs can produce different outputs, because a single sampled token chosen slightly differently can redirect everything after it. This is also why settings can change the tone of a response without changing the underlying model at all. 1 token selected, but we've only generated 1 token, which brings us to the loop, and this is where the whole thing clicks. That new token gets appended to the input, and the entire process runs again from scratch. Tokenize, embed, transform, probabilities, sample. Every token, start to finish. First pass on explain Python to a beginner picks Python. Now the model sees explain Python to a beginner, Python, and everything starts over. New tokenization. New embeddings. New attention over the whole string, including the token it just picked. New probability distribution. New sample. This time maybe is, then a, then programming, then language. The whole 96-layer machine grinds through for every single word, and this keeps looping until the model produces an end-of-sequence token or hits a length limit. This is why long outputs feel slower. Every new token requires attention over every previous token. And this is why the model genuinely doesn't know what it's going to say in advance. There's no hidden script, no sentence waiting to come out at token 10. Token 50 hasn't been decided yet. Each word is chosen only when it's that word's turn, based on everything that came before it. Now that you can see the mechanism, 3 insights fall out of it. First, hallucination isn't lying. A standard language model has no human intent. It's producing text that pattern matches what a confident, true-sounding response looks like, and the probability distribution doesn't know truth from plausibility. So always verify factual claims, especially when the model sounds most confident. Second, temperature doesn't make models more creative. It just makes them more likely to pick lower probability tokens. What we call creativity is us interpreting that randomness, which means for deterministic tasks, coding, extraction, formatting, use low temperature. Third, context limits are computational, not commercial. Standard attention scales quadratically. Every token has to attend to every other token, although modern architectures use tricks like sparse attention and caching to soften that. Either way, when you hit a context limit, it's the architecture talking, not the company being stingy. Next time you use an LLM, you'll see what's happening under the hood. Your text becoming tokens, tokens becoming meaning vectors, attention connecting context across the entire input, 100,000 probabilities collapsed into one selection. Then the whole loop runs again for the next word, and the next, and the next. An LLM doesn't write answers the way a person writes them. It calculates the next possibility, commits to one choice, and builds the illusion of a complete thought, one token at a time, until it decides to stop. Break it, map it, understand it, score it, choose it, repeat. Understanding that mechanism is what turns you from a user into a builder. If this helped, hit like and share. Thanks for watching.